Good day, viewers all over the world. You are welcome to Traded Online class. So today we want to consider permutation, permutation and combination. So we want to consider permutation and combination. So that's what we want to consider for today. Permutation and combination. So what is permutation and what is combination? The neutral meaning of permutation simply means arrangement, while combination simply means selection. So what is permutation? Permutation is the arrangement of objects taking into account the different order of arrangement. That is permutation. That is when we consider the arrangement of objects and we take into account different order of arrangement. So the number of different arrangements of n different objects is denoted as n factorial. That is where n could be any natural numbers. It could be 1, 2, it can even be 0. So when we consider the arrangement of objects, then we talk about n factorial. What is the meaning of factorial? Factorial simply means you multiply and reduce until you get to 1. For instance, if you have 3 factorial, the meaning of 3 factorial is 3 times 2 times 1 until you get to 1. So, and this will give us 6. So, and if you have, say, n factorial simply means you reduce by 1. That is, you have n minus 1 into bracket n minus 2 into bracket n minus 3 factorial. Whenever you want to stop, you put factorial there. Just like if n is equal to 3, this will be 3 minus 1. This will be n. It will first be n into n minus 1. So this will be 3 multiplied by bracket connotes multiplication. 3 minus 1 is 2. Multiplied by 3 minus 2. So this will be factorial. So 3 minus 2 is 1. That will be 1 factorial. And of course, we should know that 1 factorial is equal to 1. And 0 factorial is also equal to 1. So let's note that 1 factorial is 1 and 0 factorial is also 1. So this is just introduction into arrangement of items or objects. That's the introduction. Okay. So when we are now talking about permutation simply means arrangement of objects taking into consideration different order of arrangement. Now, if you have n objects, let's say we have n objects, the permutation of n objects taking r at a time is denoted as n permutation r. That is, when we have n objects, we are taking r at a time. The arrangement will be n permutation r. And by formula, is given as n factorial all over n minus r factorial. So this is the formula for permutation. When we have n objects, I want to take r out of n at a time. Then n permutation r is given as n factorial divided by n minus r factorial. And that is the formula for permutation. So we are going to give one. Let's give about 2 or 3 examples under this before we go into different types of permutation. So, example. So evaluate the first one, 6 permutation 3. Then we have 8 permutation 2. Then probably the third one, 5 permutation 4. So how do we get this? We start with the first one, where we have 6 permutation 3. So when we have n permutation r is given as n factorial all over n minus r factorial. So in this case now, we have 6 permutation 3. This is going to give us 6 factorial all over 6 minus 3 into bracket factorial, all factorial. So in this case now, what is 6 factorial? Okay, we concentrate on the denominator. 6 minus 3 is 3 factorial. This is 3 factorial. Then we have 6 factorial. Then how do we get this? I can reduce this up to 3 factorial. I mean the numerator. That is, I would say 6 times 5 times 4 times 3 factorial. So once I want to stop the reduction, I put factorial at the back of the last digit. Then all over 3 factorial. So 3 factorial can take care of 3 factorial. So 6 times 5 is 30. Then 30 times 4 is 120. So 120 will be the final, will be the answer here. So when we want to take 6 permutation 3, that is, we have 6 items or 6 objects. I want to take the arrangement of 3 at a go. Then this is what we have. Then we go to the second example, B, where we have 8 permutation 2. So 8 permutation 2 is going to give us 8 factorial all over 8 minus 2 factorial. This will be 8 factorial all over 8 minus 2 is 6 factorial. So we are going to get 8 times 7 times 6. I'm going to reduce it as 6 because I have 6 at the denominator. And this will be 6 factorial. So 6 factorial can take care of 6 factorial. I'm going to get 8 times 7, and that's 56. So that will be the answer there. That will be the answer there. Then we go to the third one, where we have 5 permutation 4. 5 permutation 4. So 5 permutation 4 is going to give us 5 permutation 4. 5 permutation 4 will give us 5 factorial all over 5 minus 4 factorial. And that will be 5 factorial all over 5 minus 4 is 1. That will be 1 factorial. Of course, the implication of this is that I'm going to reduce 5 factorial up to 1 because 1 factorial is 1. So I'm going to have 5 times 4 times 3 times 2 times 1 all over 1 factorial is 1. So 1 becomes 1. It does not even have any effect. So 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. So the final answer is 120. So that's what you get there. So we're going to get 120 there. So permutation, we said it has to do with arrangement. The combination has to do with selection. So I'm going to take another example. Let's say example 2 before we go into different type of permutation. In this example now, we have that we have to find the number of waves the letters of the word table can be permuted. So this is the question. That is, we want to look at the number of ways that we can arrange the letters of this word at a time. Then what do we do? There are 5 letters here. The word table has 5 letters, different letters, so 5 different letters. Then how do we permute this? Since we have different letters, 5 different letters, then the permutation of this will give us 5 factorial. It's going to give us 5 factorial because these are different letters. Okay, so how do we arrange this? I can first pick T, pick A, then bring L here, E before B. So the total arrangement that we can actually get under this, because we have 5 different letters, will be 5 factorial. Then 5 factorial, of course, will be 5 times 4 times 3 times 2 times 1, and that gives 120. So that will be 120 ways. So the number of arrangements of the letter of the word table, we can actually do that in 120 ways. So that is what we are asked to do. Then I will quickly introduce cyclic permutation. Cyclic permutation. Cyclic permutation. So I will only explain cyclic permutation. So when we have arrangement of objects or items in a circular form, then the permutation is actually given as n minus 1 factorial. That is, let's say we have arrangement of items or object in a circular form. So how do we find the permutation? The number of permutation will just be, we have to start from somewhere. For instance, if let's say in a bit sound we have about 8 bits round a thread. So how do I find the permutation? We have to fix a point here. We have to pick one as the starting point. Then we count others. So it will be n minus 1 factorial. That is what we are going to get. That's what we are going to get. Then if that circular arrangement involves human being, of course, in case of human, we can't consider it the other way around. Then it's going to be n minus 1 factorial. But if it's it's just non-living thing, something we can actually toy with, then the arrangement will be n minus 1 factorial divided by 2. For instance, that bit now, I can do the arrangements at this surface, then I can actually turn it over to also do the arrangement the other way around. But if it's human being cannot be turned upside down. So arrangement of object or arrangement of living thing in a circular way will be n minus 1. But if it's inanimate object that is not living thing, then we are going to divide it by 2. So I'm going to use example to explain further on that. For instance, let's say example 3. If you have, the question says, in how many ways can 6 members of a board of directors of a company be seated round a circular table? So look at in this question now. The question says, in how many ways can 6 members, there are 6 members here, 6 members of a board of directors of a company be seated round a circular table? Of course, if it's around a circular table, there are 6 members there. So in how many ways can we actually arrange them using this type of table? What we have, because in this case now, this has to do with human being. So we can only consider it at a go. The table cannot be turned upside down. So we only focus on, since we are dealing with human living thing now, then this is what we are going to have. So we are going to have, in how many ways? We are going to have n minus 1 factorial ways. Because for us to be able to get the number of ways, we have to fix a point. We must have a starting point. We have to fix one point. Okay, let's start from Mr. A. Then we now start the arrangement from Mr. A. Because if we don't fix the point, then we won't be able to know the number of ways. So if there are n members there, the number of ways will be n minus 1. In this case now, there are 6 members. So the number of ways will be 6 minus 1 factorial ways. Then what is 6 minus 1? That is 5 factorial. And what is 5 factorial? 5 times 4 times 3 times 2 times 1. And that will be 120 ways. So the number of arrangement will actually be 120 ways in this case. Because when we have cyclic permutation, there is need for us to fix the starting point. We fix a point as the starting point. Then we now count the leftover. So the number of ways will now be n minus, let's say we have n members there. That will be n minus 1. In this case, we have 6. If we have 8 members, that will be 8 minus 1. Then that will be 7 factorial ways that we can actually do the arrangement. So under cyclic permutation, we just have to fix a starting point. We must fix the starting point. Then let's give another example that involves non-living thing. Let's say example 4. So in this case now, the question says, in how many ways can 7 bits of different colors be traded in a circular ring? Of course, this is also it's involved a circle. It's a circular arrangement. But in this case now, we are dealing with bits which is non-living. So we can count the number of ways here and turn it the other way. So we also count. So in this case now, since there are two possibilities, then the number of ways will now be n minus 1 factorial divided by 2. But when we are dealing with living thing, it will only be n minus 1 factorial when we have cyclic permutation. But if it is inanimate object that is non-living, then we can actually divide it by 2 because we can turn it over. So in this case now, the number of ways will now be, the number of ways in this case we have 7. The number of ways will now be, that will be 1 multiplied by, because in this case now there are different colors. So we are going to have 1 multiplied by n minus 1 factorial will be n minus 1 factorial divided by 2. So how many bits do we have? 7. That will be 7 minus 1 factorial divided by 2. Then that will be 6 factorial divided by 2. And what is 6 factorial? 6 factorial simply means we reduce until we get to 1. 6 times 5 times 4 times 3 times 2 times 1 all over 2. So 2 will take care of 2. Then at the end of the day, we are going to have 3 times 4, that's 12. 12 times 5, 60. 6 times 3, 60. That's 360. So there are 360 ways that we can actually arrange 7 bits of different color in a circular ring. So that is that about cyclic permutation. Then we will quickly talk about permutation involving indistinguishable objects. That is, object that you cannot distinguish. So we quickly talk on that. Permutation involving indistinguishable objects. That is, when you have objects that you cannot differentiate, then how do we get the permutation? That is what we are about to discuss here. So if you have n objects, taking n at a time with n1, n2, n3 up to probably ni or nj. So how do we take the permutation? The permutation will be n. No, there are n objects. Will now be n, which will be equal to n1, the different options that we have, n2 plus dot 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 plus probably nj. That is what we are going to have. So how do you find the permutation? The permutation will be n factorial all over n will be addition of all the other options that we have, then all over each of these factorial of n1 factorial, n2 factorial, dot 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 up to nj factorial. So what we are trying to say in this case is that, let's say we are given n objects. So maybe in form of a word, for instance, if you have something like, maybe we have something like English. So if the question says, how are we going to take the permutation? The permutation of each of the letter of this word English. In this case now, if there are two letters, if there are letters that appear twice or thrice, then it is difficult to distinguish between them. For instance, let me use the word, let's say I want to use the word, let's say, okay, teeth. In this case now, there are two E's here. And not that we have E1, E2. I cannot differentiate between these two. So how do I take the permutation? That's what I'm trying to explain here. It will be difficult to differentiate between these two E's because we don't have E1, there's no E2. We can't differentiate between these two. Then there are two T's there, T and T. So it's not that we have T1 and T2. So how do we take the permutation of something like this? This type of question actually comes up under permutation involving indistinguishable objects. There are two T's here. I cannot differentiate between these two. The two is I cannot differentiate between this. So how do we take the permutation? But what we are trying to say is that if you want to take this type of permutation now, you count the number of letters that you have there. There are, in this case now, there are 5. So my n will be equal to 5. Then that will be 5 factorial all over how many letters are repeated. In this case now, there are two T's, 1, 2, all over 2 factorial multiplied by How many E's do we have? 2. 1, 2. 2 factorial. So this is how we solve this type of problem. Because we cannot differentiate between the first E and the second E. We cannot differentiate between the first T and the second T. So this type of problems or questions comes under permutation involving indistinguishable objects. So I will give one example on this, or 1 or 2 examples on this. Then we'll move. So example 5. In this, the question says, find the number of different arrangements of letters of the word Ogbomosho. That's the word. So in this word now we have Ogbomoso. So all the letters that we have all together in this word is 1, 2, 3, 4, 5, 6, 7, 8. There are 8. So we have 8 letters there. Out of the 8 letters, there are 4 zeros there. 1, 2, 3, 4. Then I think we have just 1 G, 1 B, 1 M, and 1 X. So what is the permutation? How do we get the permutation in this case? The permutation in this case will now be 8 factorial. You add all the letters together, divided by the letters that are repeated. In this case now, there are 4 zeros. 1, 2, 3, 4. All over 4 factorial. Every other letter has just 1. So 1 factorial is 1. We don't need to bother ourselves. But what we are trying to say under indistinguishable object is that you cannot differentiate between the first 0, the first O, letter O, and the second, third, and fourth. There's no way we can differentiate between them. So that's why we said we are going to have 4 factorial. Then if you reduce this, we are going to have 8 times 7 times 6 times 5 times 4 factorial all over 4 factorial. Of course, 4 factorial simply means 4 times 3 times 2 times 1. This will take care of this. Then 5 times 6 is 30. 30 times 7, that's 210. Then 210 times 8, that's going to give us 1680. So there are 1608 ways of arranging this letter of the word, because we cannot differentiate between the two. So it's difficult to differentiate between the two. And of course, we can have so many many examples on this. So what if you are given the word, let's say mathematics, the word mathematics. So if you have to find the number of ways we can arrange the letters of this word mathematics, what will happen? Just look at it. How many letters do we have all together? You add it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the permutation, the arrangement will now be 11 factorial all over. There are 2 M's there, 1, 2. And you cannot differentiate between these two. So that will be 2 factorial. A, we have 2 is 1, 2. That will be another 2 factorial. C, there are 2 factorial. Then every other one is 1, 1, 1. So 1 factorial is 1. So we don't bother ourselves with it. So the number of arrangement of the word, the letters of the word mathematics is going to give us 11 factorial all over 2 factorial multiplied by 2 factorial multiplied by 2 factorial. And that is what the permutation will be. And the last concept that we are going to talk about under permutation is conditional permutation. Just like under probability that we have conditional probability. So in case of conditional permutation, then we know that there will be some restrictions, because from the word conditional, so there are restrictions that will not actually enable us to do what we are expected to do. So under conditional probability, sometimes restriction can be placed on the order of arrangement of objects that are to be permuted. So once there is restriction, then such permutation comes under conditional permutation. So if that happens, then the permutation is said to be conditional. That is, once restriction is placed on the given question, then you should know that there will be you won't be able to do everything freely. So for instance, let's give an example. Find the number of ways the letters of the word the letters of the word committee. The letters of the word committee can be permuted if the two T's must always be together. So this is the question. This is the question. So if we are to find the number of ways the letters of this word committee can be permuted, of course we know what to do. We are going to add everything together. That will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of ways, the permutation will be 9 factorial all over. We now count the letters that are repeated. There's 1 C. Okay. How many M? There are 2 M's there. There will be 2 factorial. We have 2 T's, 2 factorial, then 2 factorial. This is what we ought to get. Normally, without this restriction that if the 2 T's must be together, without this restriction there, the number of ways that we can arrange the letters of the word will be this. This is the actual answer. But because this restriction has been placed there now, that we should find the number of ways that the letter of this word can be permuted if the 2 T's must be together, then that's a serious condition. That simply means that from the word committee, these 2 T's must be together. We are going to view the 2 T's as one because we can't separate the two. We don't know if you have T1 or T2. But the condition there, the condition placed on this question is that these 2 T must be together irrespective of the arrangement that we want to do. Then if that is the case, then what do? We are going to view these 2 T's as one. Then at the end of the day, we are going to have 1, 2, 3, 4, 5, 6, 7, 8. We are going to see the 2 T's as one. We see it together. So since the 2 T's must be together. So we have committee. So we are going to see. We combine the two. So we view it as one. So the number of arrangement permutation will now be 1, 2, 3, 4, 5, 6, 7, 8. We are going to see the 2 T's as one. So it will reduce to 8 factorial all over how many C? Just one. How many M? 2 factorial. Then how many E? 2 is 2 factorial. So the 2 T's must be together. So we view it as one. Then in this case, we are going to have 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial all over 2 factorial times 2 factorial simply means 2 times 1. So 2 factorial we cancel 2 factorial. 2 here 1, 2 here 2. So if we say 3 times 2 is 6, 6 times 5 is 30, 30 times 5, 300, 300 times 7, that's 200, 2,100. Then 2,100, 2,000, this 3 times 2 is 6, 6 times 5, 30, 30 times 6 is 180, 180 times 7, then times 8, that's going to give us 10,080 ways. So that's what we are going to get. That will be 10,080 ways. So under conditional probability, there are restrictions, or we have a restriction placed on maybe 1 or 2 letters of the word. For instance, also, we can be asked to find the permutation or the number of ways that we can arrange the word L if these 2 L must be together. If the 2 L must be together. For instance, in this case now, without the restriction, if you want to find the permutation on the number of ways that we can arrange the letters of this word, we had everything together. We are going to have 4 factorial all over. Then this will be all over 2 factorial because these two, there are 2 L's that we cannot separate. Then we have 4 times 3 times 2 factorial all over 2 factorial. That will be the number of ways will be 12 ways. That's the ideal thing to do. If you have to find the number of ways that the letters of this word L can be arranged. But if we place the condition that these 2 letter L are together, they must be together. So we won't separate it. Then once we place that the restriction, we are going to view the 2 letter L's as one. So we are going to have 1, 2, 3. The permutation will now be 3 factorial all over. Then every other one is 1, 1, 1. So that will be 3 factorial. That will be the number of ways. Then that will be 6 times 2, that will be 3 times 2 times 1, and that will be 6 ways. So when we place restriction on this, the letters of the word, these two letters that they must be together, then the number of ways will be 6. But without restriction, the ideal thing is that the number of ways will be 12. So I want us to note that about conditional permutation. So I will go to combination. Combination. So the topic is permutation and combination. So what is combination? Combination is the arrangement of objects in order, arrangement of objects in which order is not taken into consideration. That is, under permutation, order is taken into consideration, is key. But under combination, order is not taken into consideration. Then another word for that is selection. That is, it is also referred to as selection. Under combination, we only select. So the order of arrangement, we are less concerned about the order of arrangement. Then, if you have n objects, so the number of ways r object can be selected from n object is given as n combination r. And by formula, this is going to give us n factorial. It's going to give us the permutation. In this case, will give us n permutation r divided by n factorial. Because under combination now, the order of arrangement is not taken into consideration. It's more or less like selection. So what is, when you have r ways, how can we take r ways from n ways? Then that will be n combination r. Then n combination r is going to give us n permutation r divided by n factorial. Then what is n permutation r? N permutation r is n factorial all over n minus r factorial. And of course, we have n factorial here. That will be n factorial. Therefore, n combination r is given as n factorial all over n factorial n minus r factorial n factorial. So this is the formula to find n combination r. That is, if you want to take the number of ways r objects can be selected from n objects, this can be selected from this. So this is the number of ways in which r objects can be arranged from n objects. This one is permutation. The order of arrangement is taken into consideration, but under combination, the order of arrangement is not taken into consideration. It's more or less like selection. So this is the formula for combination. Why for permutation? This is the formula. So let's get the difference. There is slight difference between the two. Under permutation, the order of arrangement is taken into consideration, but under combination, the order of, we're silent about the order of arrangement. We just select. So that is the major difference between permutation and combination. So let's just take one or two examples under combination. Then let's say evaluate. Say evaluate A 4 combination 2. Then B, let's say 7 combination 3. So in this case now, we have created something like this under permutation. So when we have 4 combination 2, this one will give us 4 factorial all over 4 minus 2 factorial. This will be 4 minus 2 factorial, 2 factorial. So I think the formula I gave, there's a slight mistake, error there. N combination r is n factorial all over n minus r factorial. R factorial is r factorial, not n factorial, because n combination r is going to give us n permutation r all over r factorial. So please, let's take note. The formula I give us, there is slight mistake there. What we have here must be r factorial, not n factorial. So please, let's take note. And of course, n combination r in some textbook can be written as nr, something like this. Still talking about combination. Is that you call it n combination r or n something in form of a matrix? So in some textbook you can have something like this. So please, let's take note. It's r factorial and not n factorial. Okay. So this will give us, this is what we are going to get. At the end of the day, we have 4 factorial all over 4 minus 2 is 2 factorial, 2 factorial. Then here I'm going to reduce this 4 times 3 times 2 factorial all over 2 factorial is 2 times 1. Then multiply by 2 factorial. This will take care of this. 2 here 1, 2 here 2. 2 times 3, that's 6. So when we have 4 combination 2, it's going to give us 6. Then the second one, B part, it is 7 combination 3. 7 combination 3. So if you have 7 combination 3, what are we going to get? 7 combination 3 will be 7 factorial all over 7 minus 3 factorial 3 factorial. Then here we are going to have 7 factorial all over 7 minus 3 is 4 factorial 3 factorial multiplied by 3 factorial. So I will reduce this 7 times 6 times 5 times 4 factorial all over the 4 factorial will be here. Then let me reduce 3 factorial to 3 times 2 times 1. 4 factorial will take care of 4 factorial. Then 3 times 2 is 6. It will take care of this. 7 times 5, that will be 35. And that is what we are going to get from there. So we are going to take 2 more examples under combination. Then we'll close for the day. So let's take example under combination. So let's example 8 or example 9. So the question says, find the number of ways 2 prefects can be selected from a class of 15 students. So look at, in this case now, we have to find the number of ways 2 prefects can be selected from a class of 15 students. So that simply means that we are going to have 15 combination 2, because we are talking about selection here, not arrangement. We're talking about selection here. So the number of ways will be 15 combination 2. So if it's 15 combination, that will be 15 factorial all over 15 minus 2 factorial 2 factorial. Then that will give us 15 factorial all over 13 factorial 2 factorial. Then we are going to have 15 times 14 times 13 factorial all over 13 factorial multiplied by 2 times 1. 13 factorial will take care of 13 factorial. 2 here 1, 2 here 7. So 15 times 7 will be 105. So that will be 105 ways. So 2 students can actually be selected from a class of 15 students. In how many ways? 105 ways. So here now we are talking about selection. Order of arrangement does not count under combination. So we should note that. So we take another example. Where we have find the numbers. Find the number of ways a committee of 5 consisting of 3 males and 2 females. Consisting of 3 males and 2 females. Can be formed from a social club consisting of 8 males and 7 females. Look at, under combination, we talk about selection. So combination has to do with selection, but under permutation, then we talk about arrangement. Okay, so in this case now, we want to find the number of ways a committee of 5, we want to form a committee of 5 consisting of, in that committee there are 3 males and 2 females in that committee of 5. But we want to find the number of ways that we can actually select them from a social club consisting of 8 males and 7 females. So what do we do? So we are going to take it male to male and female to female. So the number of ways will be the number of ways of selecting them will be, out of 8, For the males, we have 8, combination 3. So we are selecting 8 we are selecting 3 out of 8. Okay. Then multiply by, out of 7 female, we are selecting 2. That will be 7 combination 2. This will be the number of ways by which we can actually select 3 males and 2 female from 8 males and 7 female. Then this is going to give us 8 factorial all over 8 minus 3 factorial, 3 factorial, multiply by 7 factorial all over 7 minus 2 factorial, 2 factorial. That's what we get. So from there, I will reduce 8 factorial to 8 times 7 times 6 times 5 factorial, because here I'm going to have 8 minus 3 is 5 factorial. I'm going to have 5 factorial, multiply by 3 factorial is 3 times 2 times 1. Then multiply by 7, I will reduce this also to 5. 7 times 6 times 5 factorial, because 7 minus 2 is 5. So I'm going to have 5 factorial, multiply by 2 times 1. Then if I do that correctly, 5 factorial becomes 5 factorial. 3 times 2 is 6. We take care of this. I'm going to get 56 here. 8 times 7 is 56. Multiply by this, we cancel this. Here 1, here 3. 7 times 3 is 21. So the number of ways of selecting them will now be 56 times 21. And that will give us 1,176 ways. So that's what we're going to get. 1,176 ways. Then the last question for the day is example 11, where we have find the number of ways of selecting 15 balls consisting of 5 black, 5 blue, and 5 white. 5 white balls from a box which contains 6 black, 7 blue, and 8 white. That's what we have. That is the question. We want to find the number of ways of selecting 15 balls consisting of the 15 ball consists of 5 black, 5 blue, and 5 white balls from a box which contains 6 black, 7 blue, and 8 white. Solution. How do we select this? So we are selecting 5 black from 6 black. So we have 6 combination 5 multiply by, we are selecting 5 blue from 7 black. That will be 7 combination 5. Then multiply by, we're also selecting 5 white from 8 white. That will be 8 combination 5. So that's what we have. Then if we solve this now, this is we give us 6 factorial all over 6 minus 5 factorial 5 factorial. Then multiply by 7 factorial all over 7 minus 5 factorial 5 factorial. Then multiply by 8 factorial all over 8 minus 5 factorial 5 factorial. So since I have 5 factorial, I will reduce this to 5. I'm going to have 6 times 5 factorial. 6 minus 5 factorial, that's 1 factorial. That is 1. Multiply by 5 factorial. So 5 factorial can take care of 5 factorial here. Then multiply by 7 times 6 times 5 factorial. Then 7 minus 5, that's 2 factorial. 2 factorial is 2 times 1. Then multiply by 5 factorial. So 5 factorial, we cancel 5 factorial. 2 here 1, 2 here 3. So here I'm going to have 6. Multiply by 7 times 3, 21. Then multiply by, we move to the last one. 8 times 7 times 6 times 5 factorial. All over 3. 3 factorial is 3 times 2 times 1. Then multiply by 5 factorial. This will take care of this. This will take care of this. Then at the end of the day, we have 8 times 7 to be 56. So the number of ways will now be 6 times 21 times 56, and that will be 7,056 ways. That's what we are going to get. So that's what we are going to get. So because of our time, I would love to stop here, but I want to give us a kind of exercise. Let's solve this. I want us to solve this And just put your, if you can put it at the comment section, it will be fine. The first one says that we should show that the first question, n combination n minus r is equal to n combination r. That's the first thing that we are asked to do. Then the second one, n combination r plus n combination r plus 1 is equal to n plus 1 combination r plus 1. So once we follow the step, you should be able to do what you have on the board. So let me just give a recap of what we have discussed. So when we started with permutation, and I said permutation is the arrangement of objects taking into account the different order of arrangements. So that is permutation. And I said the number of different arrangements of n different objects is equal to n factorial. That is, the different arrangement of n objects is n factorial. And n factorial simply means you keep reducing until you get to 1. So n factorial simply means n into n minus 1, n minus 2, n minus 3. Once you stop here, you are going to continue until you get to n minus n factorial. Okay, so that's what you are going to do. Then we also said that 1 factorial is equal to 0 factorial and it's equal to 1. So either we have 1 factorial or 0 factorial, it is 1. So we should note that. So that is where we started from. So please try and show this. Just try this. So from there, we give the formula for permutation. We said if you have R objects, you are taking R object from N object. The permutation will be N factorial all over N minus R factorial. And we talked about permutation involving indistinguishable objects. We talked about cyclic permutation and conditional permutation. We now move to combination. And we define combination as the arrangement of objects in which order of arrangements is not important. That is, under combination, we are talking about selection. And we gave the formula of combination as n combination R to be n permutation R all over R factorial, because order of arrangement is not necessary here, and which is same thing as n factorial all over n minus R factorial R factorial. So under combination, we looked at some of this. We would look at about 3 questions under arrangements. I gave 2 as exercise. So I would love to stop here because of our time. By the grace of God, we continue from here some other time. Thank you, and God bless you all.